Hi, welcome. Today we're going to talk about L'Hôpital's rule. That's French. There are actually two spellings that I've seen about this. I like the one that has the word hospital in it, although the S is silent, so it's actually L'Hôpital, not hospital, or La Hospital. This one, the book uses with an O with a funny thing on top. No S. Both are legitimate forms for French for this word. In order to talk about L'Hôpital's rule, we need to talk about indeterminate forms, what they are and what this means, and where it applies. It's also worth mentioning that L'Hôpital's rule was actually not discovered by L'Hôpital, but by the Bernoulli brothers. It's a long story, and I'm sure your instructor can tell you about it if you're ever curious. But let's move on to the actual work. So, what is L'Hôpital's rule? It's something to do with limits. When we do this, it's important to realize that although it's limits of ratios here, and we're going to do something funny, it's not derivatives. You don't do this for a quotient rule. This is not a substitute for that. It's a totally different thing. What does it say? It says if the f over x, the limit of that, if f of a over g of a has an indeterminate form, and what I mean by that is some weird form, we've seen them. Things like 0 over 0. What do you do if you end up with a 0 over 0? Well, you can't plug the number in, you have to do some more work. That's what we learned. Another one, plus or minus infinity over plus or minus infinity. The plus and minus, that doesn't really matter, but if the top blows up and the bottom blows up, we've got to do more work. L'Hôpital's rule is a shortcut to avoid doing that kind of work. Sometimes it was easy work, sometimes it was hard work. This is just another way to do it. And again, we're not taking derivatives. What does it do? It basically says this is equal to the limit going to the same place of f prime of x over g prime of x. Notice I take the derivative of the top over the derivative of the bottom. Sometimes Calc 1 sequences don't do L'Hôpital's rule because they're afraid students will go, oh, that's a new quotient rule, I love it. It's not. This is, I want to emphasize this. This will be like the third time out of 12 I say that, maybe. If you see, take the derivative of a quotient, you use the quotient rule. If you take the limit of a quotient, maybe you use L'Hôpital's rule. Maybe not. But it's for limits, it's not for derivatives. It uses derivatives, but it's only for limits. Now, down here, other indeterminate forms. L'Hôpital's rule only does 0 over 0 or infinity over infinity with plus or minuses involved. Other forms, there are a lot of other indeterminate forms. There's 0 to the 0. There's infinity to the 0. Actually, 0 to the 0, think about that. Anything to the 0 power is 1. But what's 0 to any power? That's 0. So what is 0 to the 0 power? Is it 1? Is it 0? I don't know. That's indeterminate. Infinity to the 0 power. Again, anything to the 0 power is 1, but infinity is really big. Maybe it's big enough to get a bigger answer. Other forms, infinity minus infinity, or 0 times infinity. All of these are indeterminate forms, but none of them L'Hôpital can use directly. L'Hôpital's rule only applies when you can write it as a fraction. Anything else you have to tweak it around to make it do a fraction, or do something else. So let's try it. Let's not worry so much about what we do when we do it. Let's just do it. So, as x goes to 3 of this, the first thing to tell is it the form that we can use? So let's plug 3 in. Top, I get 9 minus 9, I get a 0. The bottom, I get 3 times 3 is 9 plus 3, 12 minus 12, I get 0. It is indeterminate. If it is indeterminate, I can use L'Hôpital's rule. L'Hôpital's rule says that limit is the same thing as if I take the derivative of the top, divide by the derivative of the bottom. Again, this is not the quotient rule. I'm not asking for the derivative of this. I'm asking for the limit of this. Very different thing. And you got to make sure you don't interchange those two ideas. Think of it as a totally different idea. We're going back to limits and learning a new technique for them and not for derivatives. Okay, x goes to 3. Now what do? I might have to do L'Hôpital's rule again. It might still be indeterminate. But I plug 3 in, I get 6. I plug 3 in, I get 7. That's the answer. Now, this one we could have done before. It factors. You get x plus 3, x minus 3. You get x minus 3 times x over x plus 4. And you put it out. We learned a way to do this one. L'Hôpital's rule is not necessary. Might be easier. Maybe it's not even. But it comes out the same either way. What about this one? We also learned a technique here. You could have done this. Take the highest power at the top, highest power at the bottom. Why? Because when you're going to infinity, it's a special thing, right? We'd get 1/3. Now, L'Hôpital's will apply though, Because what happens to the top? The top is going to infinity squared, which is infinity. The bottom is going to 3 infinity squared, which is also infinity. This is indeterminate. So L'Hopital's will apply. We can use L'Hopital's on this. Again, we don't have to. We already knew a special technique for this, but we could use it, and we'll be able to use it for other things where that technique won't work. I'm just using it on ones we've seen to show that it will work out. We take the derivative of the top. We take the derivative of the bottom. That's not a 1/3. But here's the thing. We need to check. Plug infinity in. What do I get on the top? I get infinity. Plug in the bottom, I get infinity. It's still indeterminate. So I can use L'Hopital's again. You can use L'Hopital's rule as many times as you need to until you get something that's not indeterminate. Now, the derivative of the top is 2. The derivative of the bottom is 6. That's just a number. I don't need to check. It isn't indeterminate. It's just a number, 2/6, which is 1/3. Which again, is the number it should be. Why use this rule when we already knew how? Because sometimes we won't be able to. Because sometimes we won't have something that we already learned a technique for. This will apply to lots of other kinds of situations. Okay, let's try one more here. Let's plug it in. X goes to 0. First thing to do is check if it's indeterminate. 0. E to the 0 minus 1. So e to the 0 is 1. Divided by e to the 0 plus 1. So I get 1 plus 1. I get 0 over 2. Is that indeterminate? Hopefully you can tell. No. That's just 0. L'Hopital's rule only applies when we have an indeterminate form. If you were in a hurry and you said, oh, I'm going to try it, e to the x over the x, you would have gotten 1, which is the wrong answer. Apply L'Hopital's rule only when you have an indeterminate form. Now let's try one more. Here, as x goes to 0, 0, well, wait, what do we have? 0 times, what's the natural log of 0? Well, it's an error. But if you look at the graph, this goes to minus infinity. So this is going to be of the form 0 times minus infinity. That is an indeterminate form, but it's not a form that L'Hopital likes. We need a fraction. This is not a fraction. But there's a way to make it to a fraction. I could put one of them on the bottom. Well, not directly, I could make it 1 over or something. And which one do I want to put on the bottom? Well, I want to put the one that is easier to work with. So I'm going to rewrite this, not using L'Hopital's rule yet, as the ln of x over 1 over x. That's the same thing, right? Hopefully you can see, yeah. And now, top, what's the top? Infinity, well, minus infinity. And the bottom is positive infinity. This is now an indeterminate form that L'Hopital's rule can use. It's very hard to do this one directly, but with that, we can now do it. Because we can take the derivative of the top and the derivative of the bottom and plug them in. The derivative of the natural log of x is 1 over x. The derivative of 1 over x, quotient rule, power rule, however you do it, you're going to get minus 1 over x squared. And that may not look good, but fraction over fraction is just cross multiplying. That's not a special trick, that's just algebra. So we get the limit as x goes to 0 plus, what is that, 1 over x times x squared over minus 1. I get the limit as x goes to 0, also on the positive side still. I can cancel one of these. I get x over minus 1. And that's not indeterminate, that's easy, because as x goes to 0, that's 0 over 1, or 0 over minus 1, excuse me. It doesn't matter, it's still 0 as my answer. Hopefully these show you L'Hopital's rule can be used in cases we've already done, in cases we've never seen before, and don't use it always, because sometimes it doesn't apply. Till next time, this is Dr. Jed.